Hello everyone, welcome to this channel. Today I will solve previous year CSIR-NET June 2019 Organic Chemistry questions that were asked for 2 marks. Here I will solve 10 to 11 questions. So try to watch this video till the end so that you can learn something new. So let's start this discussion. The first question you can see that you have to tell about the correct reactivity order for the following dienes with this dienophile, that is malic anhydride. This is simple Diels-Alder type reaction, that is 4+2 cycloaddition. And if we draw the different diene, they will look like first E1-chloro-buta-1,3 diene, that will be this is, since it is E1-chloro-buta-1,3 diene A. And the second structure is E-penta-1,3 diene, that is this one, this is B. And the third one is E1-methoxy-buta-1,3 diene, that is here will be methoxy group. Now the condition for efficient 4+2 cycloaddition is that with increasing the electron density with the diene and decreasing the electron density in the dienophile, the reaction will occur fast. Since here dienophile is fixed, that is malic anhydride, this is dienophile, we have to see the increasing order or electron density for the different diene. Now here we can see that the electron rich, that is the highest electron density or highest electron rich diene will be C, then B, and the least electron dense diene will be A, since here electronegative chlorine atom is attached. Therefore the reactivity order will be like this, since more the electron rich the diene, more will be the reactivity. So we can see that the reactivity order is C is greater than B, and the least reactive will be A. Let me tell something that why the C diene is the most electron rich. Here oxygen OMe group will show -I effect, but it will also show +R effect, and since +R is greater than -I, so due to +R effect the diene will be more electron rich in comparison to A and B. In case of A, the lone pair electron of chlorine will also show +R effect, but -I of halogen is more stronger than that of +R, and due to this effect it will be less electron rich in comparison to B also, since here methyl will show +I effect and there is no electron withdrawing effect. Therefore you can say that the electron density or electron richness order will be like this, and that is also the reactivity order. So let's see next question. This question I have already discussed in my previous video, where I have solved previous year or few selected questions regarding NMR spectroscopy. So you can see the detailed solution there. I will give the link in the description box, and the answer for this question will be number of proton signal will be 4, and option number 2 will be the correct answer. Now this is a very important question. You have to tell about the product formed in this reaction. That is, the starting material is 3-chloropyridine, and the reaction will proceed through formation of benzene. At the first step, NaNH2 will abstract one proton and will form here benzene. There is form here pi bond, that will be benzene. Now this benzene will further react with sodium amide. Now the amide NH2 minus can attack at this carbon. Similarly, it can also attack on this carbon. Okay, if the amide attacks at this carbon, the generated anion will be this one, and it will further abstract one proton from liquid ammonia to form the final product. and similarly if amide attacks at this carbon, the generated anion will be this one, and in the subsequent step it will abstract one proton from liquid ammonia to form the final product. That means in this case both these two products will be formed, and we can see here option number A is the correct answer. Is it okay? Now in this question you have to tell about the condition for which the conformer B will be more stable than that of A, and you have to tell about for which R B will be more stable than that of A. Now in B you can see since both the R group are axial, so there will be 1,3 diaxial interaction with the R group and hydrogen. Now with decreasing the size of R group, the 1,3 diaxial interaction will be less, and in that case B conformer will be more stable than that of A. Now among the four given R group, we can see that fluorine is the smallest in size. So if R is fluorine, then in that case the 1,3 diaxial interaction with fluorine and hydrogen will be least, and B will be more stable than that of A. So we can say that R will be F, for which B will be more stable than that of A. This is a very important question. You have to tell about the final product for this reaction, and here the reagent is NBu4. In Br3 you can write it as NBr and Br2, and it will be a source of bromine. So there will be addition of bromine at this double bond. Now if we draw this olefin in chair form, then it will look like, and here will be methyl that is above the plane. Now first there will be addition of bromine, that is there will be formation of bromonium ion, and that bromonium ion will be formed from below the plane since methyl is above the plane. So the bromonium ion will be this one, and after the second step bromide minus will open up this bromonium ion, and the opening will be diaxial. Therefore the bromide minus should attack at this carbon to open up this bromonium ring, and the generated product will be in chair form. It will be like this, that is the opening must be diaxial, and for that the attack will take place at this carbon. If the opening is di-equatorial, then the attack can occur at this carbon, but the opening must be diaxial. So the bromide minus cannot attack at this carbon, it must attack at this carbon. Here is methyl. If we draw it in planar conformation, then if we draw the methyl above the plane here at this carbon, on the next carbon bromine will be also above the plane, and on the next carbon the bromine will be below the plane. So final product will be this one. So we can see that option number 3 is the correct answer. Is it okay? If you have any query, you can send me a mail, as the mail ID is given in this video, or you can place a comment. In this next question you have to send about the final product. Let me draw first the starting material and CO2Me. In the first step, sodium methoxide will abstract one acidic proton, and that acidic proton is this one, since it is the most acidic proton, and sodium methoxide will abstract this proton to form here anion, and the generated anion will be this one. Now you have to know between these two groups which will be better leaving group. You can easily say that this is better leaving group, and in the next step this anion will attack here to form a 1, 2, 3, 4, 5 member ring. Here will be anion, and in the next step the anion will form a double bond and SO2 Me will group will eliminate, and the final product will be this one. You can also think that this product may be the final product, or this product may be formed, and how this product will be formed, let me tell here. The anion here, you can draw it like this. The anion here will be conjugated with this carbonyl group and will form corresponding O- ion. Me, and in the next step O- will attack here to eliminate this SO2 group to form this product. Now here we can see that the ring formed here is 7 member ring, 1, 2, 3, 4, 5, 6, 7, and it is fused with 5 member pyrrole ring. Now 7 member ring fused with 5 member ring is less stable than in comparison to 5 member ring fused with 5 member ring. So due to stability reason, this product will be the major product. Now here we have to tell about the relationship between A and B. Here we can see that this double bond is E, and similarly this double bond is also E. Now this is the chiral center, and here this is also chiral center. If the stereochemistry of this group, suppose it is S, it will be S, since it is above the plane, it is below the plane. 1, 2, 3 rotation is anti-clockwise, so it is S, and this group will be 1, 2, 3, that is R. Therefore stereochemistry of A is E and S, and stereochemistry of B is E and R. Thus A and B are related as diastereomer to each other. So the relation is diastereomers. Now here we have to tell about the most stable conformer for this structure. Now as you know that chair form is more stable than that of boat or twist boat or twist chair. Boat or twist boat or twist chair. So the first these two structure 1 and 2 will be more stable than that of 3 and 4, since 1 and 2 is chair form. Now between 1 and 2, here we can see that here methyl group is axial, so it will face 1,3 diaxial interaction with hydrogen atom, but there will be no interaction, no steric repulsion with this group and the methyl group, since the methyl group is axially oriented, and due to small size of hydrogen the repulsion will be negligible with this group. Now in this structure we can see that since the methyl group is equatorially oriented, it will face severe steric repulsion with this group, and though here is no 1,3 diaxial interaction with the methyl group, but due to strong repulsion with methyl group and this group, the energy of conformer 1 will be higher than that of 2, and we can say that the most stable conformer for this structure is this conformer number 2. So this will be the answer for this question. In this question it is given that the deoxymonosaccharide A What is the meaning of deoxymonosaccharide? It is in monosaccharide, when one OH group is substituted by hydrogen atom, that is one OH group missing in the long carbon chain, that will be deoxymonosaccharide. Now in such deoxymonosaccharide A, which is reacted with 2 equivalent of HIO4 is an oxidizing species that will oxidize or cleave the carbon-carbon bond between two vicinal diol, and it will form the corresponding carbonyl compound from this vicinal diol. Now if in the monosaccharide in the terminal position there is CHO and in the next carbon OH, then it will also cleave this carbon-carbon bond. HIO4 will also cleave this carbon-carbon bond to form corresponding acid from the CHO group and the corresponding carbonyl from this CHOH group. Okay. Now here by the reaction of 2 equivalent of hydrogen periodate, the monosaccharide generates propane diol. Propane diol means CHO, CH2, CHO. This is propane diol, and one molecule of formic acid, that is HCH2OH, and one molecule of formaldehyde, that is HCHO. We have to tell about the structure of the monosaccharide A. Now in the given reaction we have to see that which monosaccharide is giving these three products. Now let us first see the first option. Here if it is treated with HIO4, since there is this one is vicinal diol, so it will cleave this carbon-carbon bond and will form the corresponding carbonyl compound. Since here is hydrogen, so it will be aldehyde, and similarly here will be aldehyde, and below will be CH2OH. And as I told here that if there is CHO at the adjacent carbon to one carbon OH bond, the HIO4 will also cleave that bond and the CHO group will be converted to carboxylic acid, and this will be CHO, that is HCHO. So we can see that this monosaccharide by treatment of 2 equivalents of HIO4 is yielding the given compounds, that is propane diol, formic acid and formaldehyde. So we can easily say that the correct answer or structure of A is this one. Now we can also check for the remaining three options, you will not get this given compound as the final as the generated product. You can try by yourself. If you feel any difficulty, you can ask me in the comment section. So this question I have also discussed in my previous video of mass spectrometry. I will give the link in the description box. You can see the detailed solution for this question. You have to tell about the compound that will show a base peak at m by z equal to 120 in the EI mass spectrum, and the answer for this question will be this one, that is option number 3 will be correct answer. And for the detailed solution you can watch my previous video as a in the description box you will find the link. This is the last question for this discussion, and here you have to tell about the final product for this reaction. Here this alcohol is treated with HBr. First of all, the OH will be protonated by H plus generated from liberated from HBr. So the product formed in the first step will be, here will be OH2 is OH group is converted to a better leaving group, that is OH2. In the next step what will happen, here the counter anion is Br minus, that Br minus open up this cyclopropane ring. If it attacks here, this carbon-carbon bond will break, it will form here double bond and OH2 group will be eliminated as water. So the final product will be this one. This is a very easy question, just you have to know that the ring opening will take place in presence of such nucleophile. Since the 3-member ring is stable, 3-member ring is strained enough to get opened, bromine. So we can see from the given options that option number 3 is the correct answer. So that's all for this discussion. If you like this video, you can also share it with your friends so that they can also learn something. And if you are new in this channel, then please don't forget to subscribe my channel Chem Analysis. Thank you once again.